Hi, in this video, I will talk about breadboards in general for prototyping your electronic projects and the various kinds of breadboards that you can get in the market today and what are the nuances related to them, how some breadboards are different from the others and what are they good for. All right, so let's get started on this. First, I should talk about the most common breadboard that you would find in the market right now, which is also called as the MB104. I think it's MB102, sorry, MB102 breadboard. And this breadboard has got about 830 pin layout. So total number of pins are totally 830 pins. And this is a very commonly available breadboard in the market today for prototyping on electronics. There are also other kinds of breadboards of different sizes, and one other breadboard worth noting is something that's slightly bigger than this, which is a 840 pin breadboard rather than this 830 pin. This 840 pin breadboard is slightly bigger. It's got a slightly higher profile, which you can see from this. It's got a slightly higher profile than this one. This breadboard is a quite old breadboard that I have. It's very hard to find this brand of breadboard which I have right now. It's actually called Wishboard, and one of the things I like about the breadboard is it's got metal shielding at the back. Oh, this metal is not connected to any of the pins in here. It's just provided for shielding purposes. It's quite rugged, quite reliable. I bought this back in 1997, so it's almost going to be like 25-year-old. Still very good, still very stable. On the contrary, you'll find breadboards like these with different qualities, and yeah, you find some cheaper ones which wear out very quickly because these pins which you use for connection, they contain small clips inside them. They can actually wear out over time. So you should have some careful handling when you're using these breadboards, and they're also quite delicate when you compare this with this one. There are also variations of this breadboard itself. First, let me tell you how this breadboard layout is. First of all, you can see there's a middle ridge that here that acts like a proper insulator. That means that there's a block of connections that come on this side. There's a block of connections on this side. There is no connection between these two sides. I have a small makeshift continuity tester which I have here. All I have is a battery pack with an LED on one side and a small dropping resistor for the safety of the LED on the other. So here what I've done is I can just plug this one end of the resistor in one of these terminals in here, and I can actually connect the LED in here. So I'll do one thing. I'll keep the LED static in one point, and you can see that when I connect the resistor onto any other points on this side, it does not provide any continuity. The continuity is provided through this line, this particular row, right? So when you click on, when you select this, or here, or here, or here, you can see that it's making continuity, right? So the continuity is made on this particular line, right? This particular line where the LED is connected. But of course, it only stops at this point, at this juncture. If you cross over to this side, it does not make any continuity. The idea is when you're placing any ICs or any boards, like if you're going to be placing a microcontroller here, you want to place it like this so that one side of the pins which are there here goes on this side, the other side of the pins rest on the other side. So you have an option to connect this particular Raspberry Pi Pico, for example, in this case, and you could actually use these pins for making connection to the appropriate connectors that you find there, right? So that's the whole intent of having the middle ridge, which is there here. Also to note is that these two lanes that you see on the corners, these are the power lines or the power rails, and these are mostly useful for delivering power to your circuitry. So if you have multiple components connected and each of them needs to draw some power, you can actually hook them up to these lanes. So normally what you do is that to the edgemost connections, you will actually connect the positive and negative of your supply. They have provided the plus symbol for representing positive, which is indicated by the red line that you see here, and the minus symbol with a blue line. Sometimes it can be black or dark green or blue green, whatever colors they are. Different color, there is a darker color to represent the negative rail here. So you connect the negative side of the battery here and the positive side in here, and they actually make continuity in this direction. You can see that when I connect the LED on the positive side, the positive line, there's just a line, it's just a line. It makes complete contact throughout. You can see that right here. So you can see it's making contact in all this positive lines till this corner on this breadboard, right? In fact, if you try to plug this on the negative rail, it does not make any contact to the positive. Obviously, it will make contact on the negative. So if you connect the positive supply pin in here and the negative supply pin in here from your power source, you can use this. You can use all these connections on this lane to connect to your devices, positive or VCC or VDD connections, and you can use this negative for ground connections, right? That's how it is designed to work. On the same line, you can on the same way you'll also find the positive and negative in here, but you can see it's sort of twisted. You can see the positive comes to the inner side, negative comes to the inner side on this side. So you have that kind of variation here. So, however, you can see there's no contact between this point to this point. Some people think that if I make a connection on positive on this side, does it make a connection on the positive on the opposite side? It does not. You need to actually connect wires. Of course, there are some more breadboards on this variation, like this one. You can see an interesting thing here. You can see the line as a gap. This gap actually means that there is no connection from this set of lanes to this set of lanes. What I mean to say that, so suppose if I connect the LED on this corner, I can make contact throughout this entire lane, connecting all over this place. You can see this right here. But the moment I cross over to the other side, it does not make any contact. You can see this. No contact is made. So though I connected the resistor to the negative and the LED to the negative in this side, there's no continuity across this location. In fact, the reason behind it is you can have separate circuitry with different power sources in here and separate circuitry with a different power source on the same breadboard. Maybe you want to have some circuits that use 3.3 volts and some circuits that use 5 volt, but you want to put them together on the same breadboard. This kind of breadboard might be useful. These are quite rare to find, by the way. So I was able to get this by random when I ordered it. So I just realized that there's a gap in between, and that actually means that there is no connection. Sometimes when you have a breadboard like this and you want to make sure that the entire positive lane is connected, one of the ways you can do that is by using a small wire like this. I have a single standard wire which is sort of properly, bent, so I can just plug this in on the positive side over here. I'm using the red for positive. That's a very common convention, by the way. Yeah, it can be a little tricky. Yeah. And I'll use the black for negative. Yeah, done. So now we can actually try it out. So I just added a jumper to jump from here to here. So now it actually connects the two different parts of this breadboard together on a common rail. You can also see it happens for positive connection too. When I connect the resistor on the positive rail here, I can move this LED in this place and you can see it's glowing. So it shows that there's continuity throughout this lane. So if you want to sort of make sure there's a complete continuity when you have boards like these, this is how you make it work. These boards are quite common, and these are suitable for boards like the ESP series microcontrollers largely, and also the Raspberry Pi Pico mainly, right? But on the contrary, you might also get some smaller size breadboards, which are of this type. This is a 170 pin breadboard, and obviously, if you try to connect the Raspberry Pi Pico, you can see it sort of spills over. It does not make a full connection. You can see that right here. This breadboard is definitely not suitable for boards like these, right? You might sometimes get some very small microcontrollers with connectors in them. You can use this small breadboard. It'll save space. For space saving, you could use this. Also, another fact is that the breadboards generally can come up fully white. Like you see here, all of these are generally white. So it's a slightly dulled down version of white anyways. You'll also get some breadboards which are also translucent, like these ones. It's actually a bit translucent, you can see that. If I bring it closer to the camera. To compare this with this, they both are functionally similar, but just that some people find this breadboard more exotic because you can actually see all those teeth in here, right? It's sort of visible. So some people find this more intuitive. So yeah, you can buy this too if it's available. In the market, I think I found this to be slightly expensive than the normal white breadboards, but functionality wise, I don't think there's any difference. In terms of reliability, I'm not sure whether this is much reliable than this. Never tested it. Same goes with even the smaller size ones. You also get the translucent version, right? And you also get this one. Sometimes, you may not be working on full-blown microcontrollers, but you might be just wiring up a transistor with some resistors or creating some very basic circuits, maybe creating a Joule-T for any kind of very simple circuitry. For that, if you want to prototype on breadboard, you can go for something even more smaller, like these ones. The ones that you see here. These breadboards are becoming very common these days, especially for prototyping very small electronic circuits. They're functionally similar to these breadboards, but they're just very small. In fact, they're designed to be fit onto a bigger board, just like Lego blocks. You can see them with a background here. I don't have the board. I couldn't get it in the market in India. So yeah, that's a limitation. But normally you can place them all in the breadboard, place them on a bigger board, plug them in and use them. So these are useful for creating very, very small circuits. And yeah, I don't think we'll be using them in any of my projects. I just bought them just for creating small hobby projects like Joule-Thief and all that. But yeah, that's about it. So these are the different size breadboards that you find. The next thing I should now talk about is when you have a breadboard, how do you actually plug your Raspberry Pi Pico inside it? Well, you can plug it wherever you want, whichever way you find comfortable. But let's say you want to use the edge, you can just try to plug them in this way. So normally when you're plugging in any microcontroller boards, be it a Raspberry Pi Pico or even ESP series boards, you need to strategically place it in such a way that you have enough pins left for making connections in here. So you should be able to connect any wires like these on this side, right, to make connections to any of the parts over here, right? So if in order to have this kind of a wire space, the recommendation is you need to make sure that you place them like this, right in the center. You don't want to put them too off like this. You don't want to put them on this side because it defeats the purpose. You'll not be able to use these pins easily to make any connections. So that's one of the challenges that you should note. So it's always better to find out the exact center point where you can place these breadboards. Some breadboards might not fit on this. Some of these microcontrollers might not fit directly on these breadboards. I found issues connecting my ESP32. Was it ESP32? I think it's ESP8266 rather. Yeah, the ESP8266. This might not fit onto this breadboard easily. Yeah, actually this fits. Sorry, this fits. It actually might be the ESP32. Let me try that. Yeah, actually I see that even this sort of fits. Shouldn't be a problem. I think sometimes you find some models of ESP8266 you need to really struggle to get this fit on this breadboard. They are designed to work on the 840 pin breadboard easily. Actually, the Raspberry Pi Pico also has the same problem. When you get a Raspberry Pi Pico with headers, like you see here, you buy a Raspberry Pico with headers. First time when you try to place them on this breadboard, it may not go very well easily. Most people think, oh my God, this can actually break because it doesn't fit in easily. It requires a little bit of pressure. So if at all you want to really make this Raspberry Pi Pico fit on breadboards like these, once you find the exact center point where you have 2 pins free here, 2 rows of pins free here, 2 rows of pins free here, now you can actually apply some pressure. When you're applying pressure, my suggestion, try use both sides and you might need to apply a little more pressure. Yeah, it's a little too difficult, as you can see here. So maybe I'm on the desk. I need to stand up and do it. Sorry for this. Here you go. So finally I was able to make this breadboard support my Raspberry Pi. Raspberry Pi is able to fit into this breadboard. Yeah, it's a little bit of a struggle. So many of you who are new to Raspberry Pi Pico and you try to fit them on this breadboard, they might think that this breadboard is not made. Yes, its reality is that this breadboard is not perfectly suitable for the Raspberry Pi Pico. It would fit easily on the 840 pin breadboard, but not on this one. But you're going to fit it on this one. You can still do it with a little bit of pressure, but make sure it's properly aligned. Make sure they're all on the sockets. You need to apply pressure equally on both sides. Sometimes you need to stand up if you're not as strong as me. If you're not I'm not a very strong person. So if you're not very strong, you might need to stand up and apply pressure. Make sure you don't apply too much pressure on one side so that the pins break. Normally these pins are flexible, because you have metal. It's all metal, so it can flex a bit. And not just that, the breadboards are generally a little flexible, so they can really seat a Raspberry Pi Pico. It shouldn't be a problem. Sometimes the Raspberry Pi Pico may not go fully inside. It may go partially in. This can sometimes cause loose contacts. Sometimes it may make or break contacts. Just check that. So make sure you have a continuity tester and test whether you're able to make a connection from this side. I'm just going to try out this pin here, this final pin that is there. I'm going to connect to the last row here. I connect the resistor on the last row, and I'll try to connect the LED on the pin. And you can see that it's making contact. This looks good, so you should be able to get this to go. And once you connect on this breadboard, I think you can connect all the devices and create your own circuits. One more thing I shall tell you is about how do you make connections. If you want to make connections, normally people go for jumper wires like these. These are available in the market, but these are quite flimsy. I mean, they wear out very quickly and they actually create a lot of loose contacts. I've seen this cheap cables that are there. They're flexible ones. They don't make the great contact in my opinion, and they sometimes wear out. And I have one of them that's worn out, which I'll show you after frequent usage. This black cap that you see here, that is gone off. That's gone off, right? You could actually use it still, but it doesn't look very nice. In fact, when you use wires like these, it's okay for very simple circuits where you can just connect the wire in one of them, and you can connect another wire somewhere here, and you can complete a circuit. Yeah, this wire doesn't go in very easily. That's a struggle, but if you try hard, you can actually push this in and you can make a contact. But you can see this wire hanging out over here makes it totally clumsy. The moment you start making about multiple wire connections, like say about 6, 7, or 10 connections, it gets totally clumsy and not very easily manageable. So my suggestion, even if you want to use wires like these, try and get the good quality ones. Yeah, you can see that the black cover just comes off. You need to place this back in. You'll get this for the most commonly when you ask for jumper wires, they'll give you this in the market. I would say avoid this, okay, if you can. You also get some of them like these. They come up in the form of a ribbon cable, normally a fat ribbon cable, or I have just pulled out some of it. And these are two male Burr connectors that you can see here. Two male Burr connectors here. This ribbon cable. You can also use this. This is a lot better compared to the jumper cables I showed you. But still, these wires come with standard sizes. Sometimes this itself can be clumsy. So the moment you start building more complex and sophisticated projects, you got to learn how to use these single stranded wires. These single stranded wires require a little bit of effort because you get them as long roll, right? So you need to cut them exactly to the size. You want to measure up the size, roughly approximate, right? You don't have to be very accurate at this, but you can get better as you practice. Let's say I want to make a connection from this point to this point. So I can just measure a length and add a little extra length for the leads. So maybe about, I'm talking about, let's say a 5 mm or more, right? So I can just leave it extra. And once I find that point, I can actually use a wire stripper to strip this. Let me find one. Okay, yeah, here it is. So here I have a wire stripper, the very common one. When you have a wire stripper, you have an option to change this, the bolt and nut, to make sure that there's a small gap here. You can see the gap in between. You can, when you use this side, it's used for cutting. You can cut the wire completely on this edge, but you can see a center point here. When you try to close it completely, it doesn't fully close. It just gives a small gap here. This to ensure that it doesn't completely cut the wire, but strip the covers from it. Strip only the PVC covers off. So if I want to show you how this works. Suppose if I want to cut this entire wire, I can just use either this side, right? Or I can use the edge. I'm just going to use the edge this time to completely cut the wire. Yes. And now I have a small strip of wire. And in this wire, if at all I want to, let's say, strip this insulation on top, I'm just using them in the center. You can see that? Using them in the middle. So I'll just show it again. Using them in here. And then I can just hold it firm, rotate a bit, remove it. And you now have the lead. You can see the lead here. I can also show you again, closer to the camera. So I can actually place this in the center, right? Place this in the center. Cut this by rotating a bit and then taking it off. This wire that you see is a single stranded wire. There's a single strand here. You closely observe, it does not have multiple cores. It has a single core. There's a single thick lead that's found here, right? Which is sized enough to fit into a breadboard. You can see this. I can now actually put this in. So the best way to do that is you can take this wire, make sure it looks as straight as possible. You can bend this way, bend another direction this way, right? Keep it properly aligned. Now I can make a contact from this side of the breadboard. Yeah, this breadboard is a little hard to work with, actually. Yes, and now I can make a contact in here. It doesn't go in very easily. Yeah, this breadboard is not the best in my opinion because may not be meant for wires of this thickness. So maybe if at all I want to try it out on another breadboard, which is this one, I think it will be much more easier. I will show it to you. I can just push this in easily and push the other end inside this easily. So this is how we can make a contact from this column or this row, you might call it, to this side. So you can test it with a continuity tester right here. So now when I plug this one into resistor here, and if I plug this the other side, which is the LED in here, it makes a contact, as you can see. It doesn't go anywhere else, right? It only makes a contact on this particular lane that you see here. Now using a single standard wire makes it more cleaner if you know how to cut it and strip them out. Sometimes people find difficult to use this. You can also get a more exotic wire stripper like this one. This is also quite popular. It's slightly more expensive tool, but you also have much more exotic and expensive tools than these, but this is good enough, right? You don't need to go anything beyond this if you only want to strip wires. So you can use this to also cut. You can cut a wire from this side, where let's say I want to cut a wire, so I can just put them inside here, this place, and I can, oh, okay, yeah, you can cut it. Now the wire is cut. Now if you want to strip the ends, you could directly add them in here, and then when you press it hard, it just strips the wire apart. You can see that. So you can also use this. You can align how long the wire is and all that by aligning this screw here. So you can adjust this the way you want. This is a more sophisticated one, but I find this is too very heavy, and this I've bought it, but I don't use it very regularly. But I find this more convenient, especially when you want to cut very small wires. And I think this is more convenient than the other form that I just mentioned. So as I mentioned here, you could actually wire them accordingly. When you're connecting wire, you just have an estimate on how long this, from where to where this wire should go, but just leave some extra length for the leads which you want to strip out, and then you can bend them elegantly, making sure they're straight, and you can connect them. So one of the circuits which I did in one of my recent classes for the Little Wizards Coding Camp is this one, like you see here. So I've used a single you can see that I've used single standard wire right here. Again, this is not the best, but you can get better than this, but you can see how I've done it here, right? At least it's less clumsier than using loose jumper cables for connecting on the breadboard. You can use this for very basic connections, nothing wrong in it, but if your circuit gets slightly more complex with a lot of components connected and a lot of wiring to be done, I think using single standard wire with a wire stripper and cutting them accordingly to size by planning them ahead would make your circuit look less clumsier. It looks clean. You can see that right here. And this is the circuit for lighting up a 7-segment display through resistors. In fact, I will be making a small video on this and demonstrating how this works and how do you program on this and all that. I'll be covering that a little later, but you get a picture on how you can make a connection. You can also see an example here where this Raspberry Pi Pico requires power source. So you can see I've used the red wire is connected to the power line, that's a V bus. It's connected to the power lane that is there, that's positive. And the immediate next pin is supposed to be the ground pin, which is connected to the negative rail on this breadboard. Negative rail on this breadboard, you can see that. Black to the negative, red to the positive rail, right? You can make wiring accordingly. So if you have any other components connected on this particular device and it wants to take this supply, you can use it. For example, on the 7-segment LED, you can see the negative rail that is there here. The negative rail that's there here is connected to this common cathode of the 7-segment display, right? You normally would have some designs like this, and yeah, using single standard wires are more comfortable compared to, or more better than compared to using loose jumper wires like these. And yes, when it comes to breadboard, I don't think there'll be a lot of option. This is the most commonly available breadboard on the market, which is the MB102 breadboard, which is also called as a 830. I mean, it's a 830 point breadboard. You have the 840 point breadboard, which is still available, but this might not be more popular. You get a very cheap versions of it. I have some couple of cheap versions of these breadboard, which is not very reliable. I wouldn't even recommend them. Okay. And secondly, last thing I should talk about is you can actually stack up multiple breadboards like this. You can see some ridges in the corner, right? And you can also see some tabs here. You should be able to plug them in like this through the ridges. These tabs can go through the ridges, requires a little bit of effort. And once done, now you can have these breadboards stacked together. So if you're creating a more complex circuitry, you can do that. And yes, these power rails can become a hassle. Sometimes you don't want them. You can actually get these power rails off. You can see it's removable. It requires you to cut this adhesive off. These are like just tied with glued with this foam adhesive that's on the back of the breadboard. So if you're able to remove this adhesive, you can remove this positive rail off if you don't need it, right? It's all possible to customize this breadboard. The last thing I should talk about is people who want to invest more. You can go and get breadboards like this one, which is the same MV102 breadboard, but on a very sturdy metal board that is there here. I think the steel board, so it's actually sturdy on the steel board with screws, and you also have the power connectors in here, right, which you can connect in your breadboard and make it work. Useful for displaying or demonstration or creating a project for demonstration. I think this breadboard will look more eloquent. And you also have the bigger size version of it, which I did buy but never used it. You can see this here. There are multiple MV102 breadboards which are all stacked up together, and there's a common power rail also added on top, which you can see. So whenever you see lines like these, right, these are mostly power rails. Even here, that means when you make a connection on this point, the connection will lead to wherever the line shows all the way till this end, right? It goes on all the way till the end. Whereas these are for connecting all the components. All right, so I just talked about basics of the breadboard and how the continuity works in the breadboard. And the last thing I should tell you is that the back of the breadboard, this breadboard has got a metal back. But most of the modern breadboards I've seen, they don't have such a metal back. They only have a small foam adhesive that's actually covering them. You can actually remove this. This is a double-sided adhesive, so you can remove this side and maybe connect it onto, you can stick it onto any flat surface, right? They're not very strong. The glue is not very strong, so don't want to hang it on a wall. They generally fall off, right? It's good for just keeping them steady on a table if you want to, right? That's why you have this double-sided adhesive here. This adhesive just worn off, and I actually stuck one of my projects on a wall, which happens to be a very simple digital clock, which I will show you. And you can see this is an opportunity to show you. So this is the front of the breadboard. There was this foam adhesive through which I stuck this on a wall. There's a small digital clock I created using an ESP32 chip, but then it wore out and it fell off, and the back looks naked. You can see that right here. In fact, this actually shows how the connections are, right? You can see these sides are connected commonly to this metal clips that are there here, right? The back of the metal clips, the common metal clips that you can see here. Whereas these go in this direction, which connects to the rails that are in here. So this gives you an understanding on how the connections work from behind, right? You can see them right here. All right then, so I hope you found this video useful to learn about different kinds of breadboards. I will be covering more on how do you now use Raspberry Pi Pico in the next video session, right? So we'll write some very basic programs to control some LED perhaps, and also maybe read from sensors. I'll show that in the next video, right? Thank you. So hope to meet you in the next video. Thank you very much. And if you have any questions, as usual, feel free to drop them in your comment section, right? Thank you all. So meet you in the next video session.